So today we are going to learn how can we multiply two matrices. दो मैट्रिक्स को मल्टीप्लाई कैसे करते हैं. Suppose there is a matrix A with some random elements 1 2 -1 and say 0, and there is a matrix B with some random elements 3 2 -4 and let's say 6. Okay, now here suppose the number of rows are R1 and number of columns are C1, sorry, and for the matrix B the same is R2 and C2. So this is the notation by which we can represent the size of the matrix. Okay, so the first and foremost condition to apply this multiplication operator onto matrix is that C1 and R2, they must be equal. Okay, this is the most important condition. Okay, and the resultant matrix which we will obtain after multiplication of these two will be of the size of R1 by C2. Okay, so far so good. So after proceeding into the multiplication of the matrix, let's see some properties of multiplication of these matrix. Multiplication of matrix. So the first property is commutative property. Okay, so what this property says is A times B is not necessarily equal to B times A. Okay, so here in matrix multiplication the order matters. We will verify this property as we move further in this video. Second property is we call associative property. Which is let's say three matrices A, B and C. So A times B dot C is equal to A times B whole times C. Okay, now the third property is distributive property. Which is A plus B times C will be equal to A times C plus B times C. Now let's see some examples regarding matrix multiplication. Let's take example 1. There is a matrix A 1 2 -1 0, and there is a matrix B 3 -4 2 and 6. So we have to find AB, which will be 1 -1 2 0 3 -4 2 6. Okay, so as we know that this is a 2 by 2 matrix and this is also a 2 by 2 matrix, our resultant matrix will be of the size of 2 by 2. Okay, now we will multiply the first row of matrix A with first column of matrix B. Okay, so let's see. 1 times 3 plus 2 times -4. So this is how we go in this matrix multiplication. Now we will do the same thing with the second column of matrix B, which will give us the second element of our resultant matrix. So 1 times 2 plus 2 times 6. Now for the third element, we will proceed the same operation with the second row of matrix A with the first column of matrix B. Minus 1 times 3 plus 0 times minus 4, and now with the second column, minus 1 times 2 plus 0 times 6. Okay, now this will become 3 minus 8 minus 3 plus 0, 2 plus 12 minus 2 plus 0, which will give us minus 5 minus 3, 14 and minus 2. So this will be the resultant matrix. Now let's see example number 2. And now let's take a 3 by 1 matrix. Let's say this is matrix A, and take another matrix which is 1 by 3. Let's say 1 2 3, which is 1 by 3. So let's see our condition. The C2 is equal to R1, so we can move further our matrix multiplication, and our resultant matrix will be of the size of R1 by C2, which will be in this case is 3 by 3. Okay, so let's see. 1 2 3, 1 2 3. Okay, so now our matrix will be the size of 3 by 3. So let's draw a big matrix 3 by 3. So as we did in our first example, first row of the first matrix will be multiplied with the first column of the second matrix. Okay, so here it will be 1, and as there are no elements in the row, so here we will stop. Now the second column, 1 times 2 is 2, is the same. 1 times 3 is 3. Now we will do with the second row. 2 times 1 is 1, no sorry 2. 2 times 2 is 4. Okay, 2 times 3. Now here will be now with the third row, 3 times 1, 3 times 2 and 3 times 3. So our final matrix will be 1 2 3 2 4 6 3 6 9. So this will be our final matrix. Now let's see example number 3. In this example we will take the same matrix but in the reverse order. Okay, so A will be 1 2 3, which is a 1 by 3 matrix, and the matrix B 1 2 3, which is a 3 by 1 matrix. Now our resultant matrix will be of the size of 1 by 1, as you can see, and our condition here is also satisfying, as C2, which is here is 3, is equal to the R1, which is here is also 3. So we can move further with the matrix multiplication. AB will be 1 2 3, 1 2 3. So the first row of the first matrix will be multiplied with the first column of the second matrix. Okay, so here we go. 1 times 1 plus 2 times 2 plus 3 times 3, which will give us 1 plus 2 plus 9, sorry 4, 14, which is a 1 by 1 matrix. Now here we also verified our first property, which is associative property, that AB is not necessarily equal to BA. Now let's take our final example, example number 4. Now let's take a 3 by 3 matrix with the element 1 minus 1 0 3 2 minus 4 1 2 minus 1, and B is also 3 by 3 matrix 0 minus 1 3 2 1 4 5 minus 2 1. Now let's see our condition for matrix multiplication, which is C2 is equal to R, which is here clearly satisfied, and the size of our resultant matrix will be 3 by 3. Okay, so let's know this. Okay, so now the first row of the first matrix will be multiplied with the first column of the second matrix, as we done in our previous examples. So 1 times 0 plus 3 times minus 1 plus 1 times 3. Now the first row of the first matrix will be multiplied with the second column of the second matrix. 1 times 2 plus 3 times 1 plus 1 times 4. Okay, now the third column, 1 times 5 plus 3 times minus 2 plus 1 times 1. Okay, so here we are done with our first row. Now for second row, the second row of the first matrix will be multiplied with the first column of the second matrix. minus 1 0 पॉज करिए एक मिनट. 2 minus 1 रुक, -1 0 2 minus 1 कहाँ है? -1 0 2 minus 1 2 into 3.
पक्का आवाज नहीं आएगी ना तेरे टाइम लैप्स में?
वो तो एडिटिंग से भी कर सकते हैं.
चल ठीक है कर दे.
तूने ऑन कर दिया है? फिर
ऑन है भाई, चल रहा है.
टाइम लैप्स
नहीं टाइम लैप्स ऑन नहीं हो सकता बीच में, तो करता जा, लिखता जा फटाफट. रिकॉर्डिंग चल रही है, टाइम लैप्स तो अपनी एडिटिंग में करियो.
ओके. Now we'll get, after calculation, 0 minus 3 plus 3, 0 minus 2 plus 6, 0 plus 4 minus 3. In the second column, 2 plus 3 plus 4 minus 2 plus 2 plus 8, 0 minus 4 minus 4, 5 minus 6 plus 1, minus 5 minus 4 plus 2, 0 plus 8 minus 1. And finally we will get, this will be 0, 4, 1, 9, 8, minus 8, 0, minus 7, 7. Okay, now that's it. Okay, so that's all about matrix multiplication. Thank you guys for watching this video. Have a nice day.